I'm sure you all remember back in elementary when the teacher first told the class about the three states of matter: solids, liquids, and gases. And there was always that one nerdy kid who would ask, what about plasma? Well, these are the states of matter that have naturally formed in our universe. However, there are several others besides these four that scientists have created over time, such as degenerate matter and string-net fluids. But probably the most important is the fifth state of matter, the Bose-Einstein condensate. Hi, my name's Rishan. I'm here to tell you what exactly the Bose-Einstein condensate is, how it works, and why it's so important. Back in the early 1900s, an Indian physicist, Satyendranath Bose, was working on a few quantum physics statistical problems and sent them to Albert Einstein to get them published. After looking them over, Einstein realized that Bose's calculations could be applied to light and atoms. Here's a quick crash course of what they found. First, all atoms have a certain level of energy in order to maintain their orbital, which is a fundamental theory in quantum mechanics. Second, atoms emit photons of specific wavelengths when they drop from one orbital energy level to another. Finally, if we were able to cool the atoms to the brink of absolute zero, some atoms fall into the same energy level and become indistinguishable. All other states follow the Pauli exclusion principle, which says that fermions, the building blocks of matter, cannot be in identical quantum states. However, the Bose-Einstein condensate, or BEC for short, breaks this rule. Let's say that this is a substance at room temperature, and these white dots represent atoms. Now when these atoms are cooled to extremely low temperatures with high precision lasers, they start to show wave-like properties. As the temperature gets closer and closer to absolute zero, the atoms or wave packets get longer and longer until they start to overlap each other. Eventually, these atoms get so tangled up that they lose their individuality. They can't tell where one atom starts or ends, and they become one large quantum system, also known as a superatom. This is the formation of a BEC. Finally, the big question: why is this so important? By using the BEC, teleportation, which was thought to be science fiction, would become a reality. Currently, the teleportation of data and photons is possible, as stated by the Institute of Tokyo. But if we could implement this on a larger scale, just imagine the things we could do. A complete understanding of this mysterious substance could lead to a world changing for the better.